we will discuss what is a pressure transmitter and how it works. In a process plant, it is often necessary to measure pressure of liquids, gases and vapors in pipes and closed vessels. This measured pressure should be then sent to a PLC which is in a distant control room. The PLC then uses this pressure value to control the process plant. Pressure gauges or pressure sensors may be used to measure pressure, but they do not have a capability to transmit the measured pressure signal to a distance. So an instrument called pressure transmitter is used for this purpose. As the name indicates, pressure transmitter is an instrument that is used for measuring pressure, which is then converted into a proportional electrical output signal, and this output signal is then transmitted to a control system like PLC. The input of pressure transmitter is the pressure to be measured, and the output signal is usually a voltage signal of 1 to 5 volt or a current signal of 4 to 20 milliamperes, which represents 0 to 100% of the measured pressure. A pressure transmitter is a device that is composed of three fundamental components: a pressure sensor, a signal converter, and a transmitter. Pressure transmitter first measures the pressure of liquids and gases using its pressure sensor. The pressure sensor senses the pressure and converts it into an electrical quantity. The signal coming directly from the sensor is small. This small signal would not be useful to us if we send it at any distance. So a signal converter is used to convert this output of the sensor into an analog voltage of 1 to 5 volt or current signal of 4 to 20 milliamperes that are easily transmittable. Now the transmitter transmits these signals to its designated receiver and displays the reading. There are many types of mechanical and electrical sensors available in the market. All pressure sensors senses the pressure by measuring a physical change within the sensor when exposed to changes in pressure. This physical change can be capacitance, resistance, or frequency. Pressure transmitters are of mainly three types. They are gauge pressure transmitter, absolute pressure transmitter, and differential pressure transmitter. Every pressure transmitter measures pressure with respect to a particular reference pressure. Knowing the pressure that a transmitter uses as its reference is very important in selecting the type of pressure transmitter to be used in a process. Before discussing about these transmitters, first let's discuss what is atmospheric pressure, absolute pressure, and gauge pressure. Earth is surrounded by a layer of air called atmosphere, and this atmosphere contains different types of gases. These gases exert a pressure on everything it touches on the earth. This pressure is known as atmospheric pressure. The air or gases surrounding the earth becomes thinner and thinner as the altitude increases, and so the atmospheric pressure decreases as we go up. Now consider a sealed container filled with gas molecules. When all the molecules in this container is removed using a vacuum pump, the pressure reduces to zero. This pressure is known as absolute zero pressure or vacuum pressure. Usually, pressure is measured using two references. One in which the atmospheric pressure is used as reference. That means we calculate the measured pressure is how much more than the atmospheric pressure, and this pressure is known as gauge pressure. In the second method, absolute zero pressure or absolute vacuum is taken as the reference. That means we calculate the measured pressure is how much more than the absolute zero pressure or absolute vacuum, and this pressure is known as absolute pressure. Gauge pressure transmitter. Gauge pressure transmitter measures gauge pressure using gauge pressure sensor. We have already discussed that gauge pressure sensor uses atmospheric pressure as reference point while measuring pressure. The sensor in the gauge pressure transmitter has two pressure ports. One port is open to the atmosphere while the other port is connected to the point whose pressure is to be measured. Any object on the surface of the earth is acted upon by an atmospheric pressure. So this atmospheric pressure exerts a pressure on both these ports. A pressure sensing diaphragm is present between the two ports. As one port is open to the atmospheric pressure acts on one side of the diaphragm, while the pressure to be measured along with the atmospheric pressure acts on the other side of the diaphragm. Atmospheric pressure on the opposite sides of the diaphragm gets cancelled each other and the gauge pressure is obtained. Different types of measurement technologies like piezoresistance, strain gauge, capacitance, etc. is used to measure the deflection of the diaphragm. As altitude increases, the atmospheric pressure changes. But as gauge pressure is independent of atmospheric pressure, gauge pressure does not change at any altitude. Absolute pressure transmitter. Absolute pressure transmitter measures absolute pressure using an absolute pressure sensor. Absolute pressure sensor uses vacuum as reference while measuring pressure. The sensor in the absolute pressure transmitter has two pressure pots. One pot is vacuum sealed, that means all the molecules in that pot were removed while manufacturing the transmitter. And the other pot is connected to the point whose pressure is to be measured. As one pot is vacuum sealed, atmospheric pressure does not act on it, while it acts on the pressure to be measured. The vacuum pressure and the pressure to be measured acts on the opposite sides of the diaphragm connected between the pots, and the diaphragm deflects towards the direction of more pressure. As altitude increases, the amount of gas molecules in the air decreases, leading to a decrease in the atmospheric pressure. This means at different altitudes, measures of absolute pressure will give very different readings. As absolute pressure measurement uses a constant zero pressure or vacuum as reference, absolute pressure measurement is desired in applications that require high accuracy. Differential pressure transmitter. The sensor in this type of transmitter has two ports. One is high port and the other is low port. A diaphragm is present between these two ports, that is high side and low side. One side of this diaphragm receives pressure from high port while the other receives pressure from the low port. Any difference in pressure between the two ports causes the diaphragm to flex from its normal resting position. This flexing is translated into an output signal by using different technologies depending on the manufacturer and model of the transmitter. These transmitters are generally used to compare different types of pressure. An increasing pressure applied to the high port of a differential pressure transmitter will drive the output signal to a greater level, while an increasing pressure applied to the low port of a differential pressure transmitter will drive the output signal to a lesser level.